Welcome to Master Talker online class. Today we'll be talking about simple harmonic motion. If you have not watched my video on circular motion, please do so. It will help you to understand simple harmonic motion. Okay, simple harmonic motion is the periodic movement of a body or particle along a straight line such that the acceleration of the body is always directed towards a fixed point, which is the center of the motion, and it's proportional to the displacement of the body from the point. Okay, these are not what I want to do. Okay, let's talk about the calculation part of it. You can go and read about what simple harmonic motion is and the rest of it. I'm interested in the calculation. Okay, now from our video on circular motion, I told you something, that the relationship between the linear and the angular is just for you to add r to it. Okay, for instance, linear distance or displacement is the same thing as what? Angular displacement times r. That is for displacement. Now let's go to velocity. Linear velocity or normal velocity is equal to what? Angular velocity times r. Okay, let's go to acceleration. Normal acceleration is equal to what? Angular acceleration times r. So these are the things you need to note. Okay, these are the things you need to note. But in simple harmonic motion now, in simple harmonic motion, don't forget that. Permit me to clean somewhere here so you see the velocity very well. Okay, this velocity is acting this way. Okay, so if the velocity is acting this way, let me assume that how do I put it, that if this thing is moving, okay, you know that this thing is moving like this, and when it moves, maybe say, let me say that the velocity come down here. There's something I want to show you. Okay, that you know Pythagoras theorem, if here is 90, Pythagoras theorem said that what? R squared is equal to what? X squared plus what? V squared. Okay, so my V squared will now be what? This one will move here to be what? R squared minus X squared. So therefore my V is equal to what? The square root of R squared minus X squared. Okay, there is something I want to show you here. Okay, and that is that we know that acceleration. Okay, let's talk about velocity first. We know that velocity V is equal to what? Angular velocity times what? Times r. Okay, now that is the maximum acceleration, maximum velocity. That's the maximum velocity this simple harmonic motion can attain. Okay, but if you want to calculate the velocity on the x-axis, simply w in brackets of, in fact, w this, you now use this man. Okay, because we have x here, w the square root of what? R squared minus x squared. Okay, that is if you want to calculate the velocity on the x-axis. So for acceleration, we know that acceleration normally is equal to what? Angular acceleration times r. Okay, angular acceleration times r. Okay, or there's another formula. Don't forget that acceleration is equally what? Angular velocity squared r. I told you this formula in my former video on circular motion. So if I decide to use this one, that a is equal to what? Angular velocity squared times what? R. This is the maximum. This one is the maximum velocity. Okay, this one is the maximum acceleration. So but acceleration at x-axis is equal to what? W squared. In fact, minus, because here will be minus. Okay, it will now be what? Minus w squared x. Minus w squared x. Okay, this formula is very, very important. These two formulas, these are the very two important formulas you need to know for now. Okay, so that is that. Okay, so let's talk about the terms in simple harmonic motion. The terms in simple harmonic motion. Okay, the first one is called amplitude. Oh, why did I clean that? Okay, the first one is called amplitude. The first one is what? Amplitude. We represent it as what? A. They say that what? Amplitude, this is the maximum displacement, okay, from the equilibrium, that is the center point, the maximum displacement from the center, and amplitude is equal to what? R. Amplitude is equal to R. Okay, so number two is now period, and period we represent it as what? T, capital letter T, period T. And they say that this is the time taken by the particle or body to complete one complete circle, okay, or to make one complete circle, okay. That is the motion of to and flow. It must go like this and then come back, okay. It must go and come back. Before you talk about that, that is a complete that is period. It must be complete, okay. So the next one is frequency. Number 3, frequency F. Okay, this is a frequency. This is the number of circles per period. The number of circles per period. Okay, the number of what? Circles per period. Don't forget that period T is equal to what? The normal time over the number of circles. The number of circles. Okay, let me call it cycles. Okay, but you need to know that F is now the inverse of T. The inverse of T. F is the inverse of T. Okay, don't worry, I'm going to tell you how to know all this formula. Okay, so you need to know that angular velocity is equal to what? Omega T. Don't forget this formula. It's equal to omega T. Okay, and then we know that and don't forget that, okay, for a complete circle, our theta is going to be 2 pi. For a complete circle, that is 360, 2 pi, okay, and that 360 is equal to what? WT. Then we now have that what? Our W is now what? Let me call it W, the capital letter T, okay, and our W will now be what? 2 pi over what? Over T. But I know that W is equal to what? 2 pi times 1 over T, and 1 over T is equal to the frequency. So my W is equal to what? 2 pi F. Okay, 2 pi the frequency. So that is that. So let's solve some question from here. Then we now move to period of simple pendulum. So the major thing we need to know here, let me show you the major thing we need to know. The first one we need to know is that what? That normal velocity is equal to what? Angular velocity times R. Is it not? That is the maximum velocity. This is the maximum velocity. But the velocity along the x-axis is equal to what? W, the square root of what? R squared minus x squared. Don't forget that x must be minus. Okay? And don't still forget that acceleration is what? Angular velocity squared with R. Okay, and this is called the maximum acceleration it can attain. But the what? Acceleration along the x-axis should be what? W squared, minus W squared. In fact, or W squared times that minus x. No longer squared, because I'm not using both of them, I'm using just one. Okay, so what do we have now? It's as good as saying that the arrow there is 0. Okay, or use the same formula. You can use the same formula. That arrow there is 0. So if the R there is 0, we're having that minus this. Or just use this formula. Don't say that R is 0, just use this formula. Okay, so what do we have now? We are now having that my A along the x-axis is what? Minus W squared x. So these are the 3 formulas you need to know. Then the fourth one, or the 4 formulas you need to know. The 4 of them. Equation 1, equation 2, equation 3, equation 4. Now another one you need to know is that that angular displacement theta is equal to omega t. Okay, how did we get the omega t? Don't forget that what? Omega, angular speed, is equal to what? Angular displacement over what? Time. So if you cross multiply, you're having this. If you can remember this, and then remember that what? That for a period, if you want to change this t now to period, that's what the theta is going to be complete circle, and complete circle is 360, or you say 2 pi. Okay, 2 pi is equal to what? W period. Okay, so therefore if you make W subject of formula, you're going to have what? 2 pi over what? Over t, or you say what? 2 pi f, because f is equal to 1 over t. So these are the 4 or the 5 formulas you need to know, and then we are good to go. So let's start solving some beautiful questions. The first question here said a simple harmonic motion. A simple harmonic motion. Okay, a simple harmonic oscillator. Okay, a simple harmonic oscillator. A simple harmonic oscillator has a period of 0.02 seconds and a period of 0.02 seconds and amplitude of 0.25 meter. Then they say calculate the speed, the speed in meter per second at the center of the oscillation. Okay, solution. Now what do we have? Let's get our formulas, or what we are given. We are given the period t, that t is equal to 0.02 seconds. Okay, we are given what else are we given? They gave us the amplitude A as what? 0.25 meters. Okay, then I say we should calculate the speed. Okay, but there is a formula we know. And that formula said that what? The normal velocity is equal to what? Angular velocity times what? Times r. Don't forget this formula. Okay, and we know that our theta is equal to what? W what? W theta times time, is it not? Because W is equal to WT. Okay, did they give us t? Then to change the t to t, I want to change this to t. I'm going to have 2 pi is equal to what? W times the big T, because I want to get my W. So my W will now be what? 2 pi over T, is it not? So therefore my W is equal to 2 times my pi is 3.142, or let me leave it as pi. Okay, I'm going to leave it as pi. That is 2 pi over my 0.02, which will give me 2 divided by 0.02 will give me 100 pi in rad per second. So how do we get our radius? Don't forget that I told you that amplitude is equal to r. Don't forget, there's a place I told that amplitude is equal to r. So therefore my v is equal to my w, 100 pi, okay, times my r, 0.25. So what we have? W is now what? 25 pi in what? Meter per second. So 25 pi in meter per second. So that is the answer. You see, very simple question. So let's take another question. Another question says the frequency of vibration of an oscillator is 4 Hz. 4 Hz, okay? And I have if it makes 12 vibrations. If it makes 12 vibrations in t seconds, then they say calculate the t. Solution. calculate the T. They gave us F, and the F they gave us is what? 4 Hz. It can help us calculate our T because we know that our T is what? 1 over F. Okay, so which is what? 1 over 4 in seconds. Okay, so they say that that it makes 12 what? 12 vibration. It makes 12 vibration. There is something that we know. We know that our normal T is equal to what? Our normal T is equal to, what am I saying? Our normal T is equal to the small t all over what? The number of vibration. Don't forget, our small t all over the number of vibration or the number of circle. Okay, sometimes we call it number of circle or number of vibration. Okay, so I'm having that the normal t we got as 1 over 4. So 1 over 4 is equal to small t all over 12 vibration. So if I cross multiply, I'm going to have that 4t is equal to 12, and then t will now be what? 12 divided by 4, which is what? 3 seconds. 3 seconds. Okay, so let's solve another question. They said a body moves in simple harmonic motion between two points 20 meters on the straight line. Okay, on the straight line, joining the points if the angular speed of the body is 5 rad per second. Calculate its speed. Calculate its speed when it is 6 meters from the center. When it is 6 meters from the center, okay, from the center of the motion. Okay, now we are having, let me have a circle like this, okay, and from the center to this place is the radius, and the radius they gave us is what? They gave us the complete 20. Is it the complete 20? Okay, they said that a body moves in simple harmonic motion between 2 points 20 meters on a straight line. Between 2 points 20 meters on a straight line. Okay, 20 meters on a straight line. This is the complete 20 meters. So the radius is half of it, which is 10 and 10. Okay, this is 10 and 10. And then I told us that what? That it is 6 cm from the center. So from the center to maybe a particular point here, that is my S, that is my 6 meters. Okay, so that is that. So the next thing we should calculate the what? The distance. But I know that distance with the speed, I know that the normal speed is equal to what? The angular speed. Calculate the speed when it is 6 meters away. So the speed of the x is what we want to calculate. The velocity of the s. No, speed is velocity. So the total velocity normally is supposed to be wr, is it not? But the velocity of x, okay, is equal to what? W, the square root of what? R squared minus x squared. Don't forget. So from here, my r is half of that 20, which is 10 meters. okay, and my x is that point from the center, which is 6 meter. So if you now put it, you now see that the velocity x will now be what? Omega. They gave us omega, angular velocity as 5. So I'm having 5 the square root of 10 squared minus 6 squared. So I'm having what? Vx is equal to what? 5 the square root of 100 minus I'm having 64. 100 minus 16 will give you 64. So Vx is equal to what? 5 times 8, because the square root of 64 is 8. So 5 times 8 is what? 40 meter per second. 40 meter per second. Okay, so that is that. So thank you very much for watching. In our next video, we'll talk about period of a simple